Hello everyone, welcome to Neelam tutorial, and in today's video here we are to tell about some of the very important questions from aldehyde ketone. So already I have done last two videos. You might have seen part 1 and part 2. So if you have seen part 1 and part 2, you might have gone through the most important questions. Other than that, I found these questions also to be the very important one. Perkins condensation reaction. You can find it in your book. Next you have Clemmensen reduction and Wolff-Kizner reduction. These are very easy. Just you need to remember the reagent and you need to understand that which exactly reaction is this. Iodoform test, I have already explained you this in the alcohol, but still then I'll be clearing the confusion right in this as well. Next, I have action of methanol with ammonia. So these are some of the very important reaction I find. Now, what exactly is Perkins condensation reaction? So basically, Perkins condensation reaction says that when benzaldehyde. So what exactly is benzaldehyde? So benzaldehyde is C6H5. Basically, benzene is C6H6. Benzaldehyde is one of the hydrogen is removed, and instead of that, there is an aldehydic group. So what it is saying is when benzaldehyde is heated with, so you need to heat it with an anhydride. What is anhydride? Anhydride of an aliphatic carboxylic acid. So let me take a carboxylic acid. Aliphatic carboxylic acid is like CH3, C double bond O, OH. Next, what it is saying, containing alpha hydrogen. So alpha, the carboxylic acid must contain alpha hydrogen. Alpha for this is this carbon, and the carbon contain hydrogen. So yes, we can make for it from it. If I am taking two carboxylic acid, CH3, C double bond OOH. So basically, this H and this OH group will come out, and this is gonna form something like this. Let me draw right over here. It will look CH3, C double bond O, C double bond O, CH3. And this is what we call anhydride. Okay, now let me remove this. I just did it to show you how is anhydride formed. Next, what it is saying is, in the presence of a catalyst. So what is the catalyst it is asking? Sodium salt of the same acid. So my acid was CH3COOH. Now instead of CH3COOH, there will be Na because it's saying sodium salt. And it need to be heated at a temperature of 180 degree C. Now what will happen is the alpha carbon was this, right? Now I can represent, I think, the three hydrogen in the form H, H, and H. Okay. Now the three oxygen is there, so this H will be taken away by this O, okay, and this will link up in the format C6H5, CH double bond CH, C double bond O, O, and there you will have H. This is what we call cinnamic acid. So what exactly is formed over here is this carbon. The carbon will be directly connected with the alpha carbon of the anhydride. And the bond of the other group will break right from this point to make another group that is CH3COOH. That is your ethanoic acid. So this reaction is basically known as your Perkins condensation reaction. So what is it exactly? When benzaldehyde is treated with ethanoic anhydride in the presence of the sodium salt of the same acid we have used to prepare the anhydride, it will give us cinnamic acid. So let me repeat again, when benzaldehyde is treated with ethanoic anhydride or acid anhydride, and the catalyst will be the same acid which is used to prepare the anhydride, its sodium salt will be used as catalyst at a temperature of 180 degrees C will prepare cinnamic acid, and this process is known as Perkins condensation reaction. Okay, let me move on for the other two. What exactly is Wolff-Kizner reduction? And sorry, what is Claisen condensation and Wolff condensation reaction? Reduction reaction, sorry. So there you have Clemenson reduction reaction. So what it basically says is for any carbonyl compound that is aldehyde and ketone, if you want to convert aldehyde and ketone into alkene, if you want to convert aldehydic group or carbonyl group into alkenic group, okay, basically what is its reagent? So we will have its reagent is zinc amalgam, that is ZnHg. So its reagent is zinc amalgam, zinc amalgam is its reagent in the presence of conc, and the reaction will take place in the presence of conc HCl. Okay. And what will it give? It will give you alkane. So basically, what is Classen's condensation reduction reaction? So when carbonyl compound, aldehyde or ketone basically, is treated with the zinc amalgam or ZnHg in the presence of conc HCl, it will give you alkane. So what you need exactly? You need either aldehyde or ketone. You need aldehyde or ketone and you need to treat it with zinc amalgam, ZnHg. So in the presence of conc HCl. So what type of agent is it? It's used as a reducing agent. You might be knowing that. Reducing agent means addition of hydrogen or removal of oxygen. So what will happen? The carbonyl group, that means if there is something like this, like an aldehyde also we have C double bond OH, right? In ketone also we have C double bond O group. So what will it exactly do is the C double bond O group will convert into CH2 group exactly. Just you need to put in mind this thing. Clear? So simply what you need to understand is the process of conversion of carbonyl group, that is C double bond O group into CH2 group by the help of ZnHg and conc HCl is known as Claisen condensation reaction. Let me explain. Sorry, Clemenson reduction reaction. Really sorry. Repeatedly, I'm just having other word in my mouth. Next, I have CH3, C double bond O, H, and let me again reduce it in the presence of ZnHg and conc HCl. What will again happen? The C double bond O group will be removed and it will give CH3, CH3. Next, I have CH3, CH2, C double bond OH, treating it in the presence of ZnHg and conc HCl. What will happen? So this carbonyl group will be removed and there will be the formation of CH3, CH2 and CH3 along with the liberation of water. Okay, so what I can see right over here is here your product is ethane, here your product is propane. So what you need to understand, alkanes are formed from aldehyde. So this process is, or we can take ketone. Let me take another example. There I have CH3, CH2, C double bond O, CH3. And again I'm treating it with the another reducing with the same reducing agent ZnHg in the presence of conc HCl. Okay. What will again happen? So this CO group will be replaced by CH2 and this will be CH3, CH2, CH2 and CH2 along with the liberation of H2O. So simple the process of conversion of this carbonyl group into CH2 wherever it is. Carbonyl into alkane, carbonyl into alkene. So this process is known as in the presence of ZnHg and conc HCl. And this process is known as Clemenson reduction reaction. Let's move on for the next one, that is your Wolff-Kizner reduction reaction. Next we have Wolff-Kizner reduction. So what exactly is Wolff-Kissler reduction reaction? Again, it is somehow same. Again, its target is same, that in order to convert carbonyl carbon, carbonyl carbon into alkane. Simple. Okay. So what is its reagent basically? Wolff-Kissler reagent. What is the reagent being used in this reaction or catalyst being used? So it basically uses mixture of mixture of hydrazine. What is hydrazine? So hydrazine is NH2, NH2. Okay. So mixture of hydrazine and strong base, strong base, that is KOH. So this is basically known as your Wolff-Kissler reducing agent. Okay. So what is that? Hydrazine and a mixture of strong base KOH. Okay. So you need these two. So let me show you with the help of reaction. And basically, again, the same term is right over here as well. You need aldehyde. So you need aldehyde or ketone. You'll be treating it with hydrazine, that is NH2, NH2. You'll be treating it with hydrazine. What will come out? So in the first step, you will find water to come out. And then whatever the product you will have right in the middle here, you are having hydrazine. Okay. And what will form right over here is you will have hydrazone. Okay, you will have an intermediate over here, which is an hydrazone, which is further being treated with KOH. Okay, in the presence of, basically you can call it KOH in the presence of ethylene glycol. Ethylene glycol. You might be knowing what is ethylene glycol. Ethylene glycol at 200 degrees C. So it basically gives us alkane. Okay, so this is what you need to know. Let's move on further. That we have CH3, C double bond O, CH3. Okay. We need to treat it with hydrazine, that is NH2, NH2. Okay. What will exactly happen in the first step? So, this H2 group will be taken away by this O, and it will form an intermediate by the liberation of water, and they will form an intermediate hydrazone, which looks like CH3, C, CH3, double bond N, NH2. Now, this is further being treated with KOH in the presence of ethylene glycol, ethylene glycol at 200 degree C. Okay. So what will it form? Basically, it is going to form something like this, an intermediate product, which will be this bond will break and this N2 will come in the form of gas, and this hydrogen will come and attach right at this point to make CH3, CH2, CH3 along with the liberation of N2 as gas. Okay, so the first step was here we have the first step that the aldehyde group is being treated with hydrazine. Now it forms a hydrazone, which is further being treated with the KOH in the presence of ethylene glycol at 200 degrees C to form a normal alkane along with the liberation of nitrogen gas. Okay, next one more. Let me show you an aldehyde group. Sorry, there I have CH3, CH2. C double bond O H again. I'm treating it with hydrazine. You already know NH2 and H2. Again, we will have the same step. The H2 will be taken away by this O. And here you will have the reduction of liberation of H2O. The intermediate those formed or the hydrazone those formed will be CH3, CH2, CH double bond N and H2, N and H2, and again which is being treated with KOH, okay, in the presence of ethylene glycol at nearly 200 degrees C. Okay. To make a product which looks like, again, this 2N2 will come out and this 2 hydrogen will come and attach right here. And the product will be CH3, CH2, CH3, along with the liberation of nitrogen gas. So in this way, alkene is being formed by Wolff-Kizner reduction reaction. Next, we have how to do the iodoform test or what type of aldehyde and ketone gives positive iodoform test. So that's our next one. Let's go for it. I have already explained you about iodoform test, but still then let me repeat it. Iodoform test. Iodoform test. So what exactly is this? So for iodoform test, what were the reagent? So reagent being used was NaOH and I2. Okay. So NaOH in iodine solution, alkaline solution of iodine, is being alkaline solution of iodine is being used for the iodoform test. Okay. Now what type of aldehyde basically? कैसा aldehyde इसका पॉजिटिव टेस्ट देगा और कैसा aldehyde इसका नेगेटिव टेस्ट देगा? तो मैंने शायद आपको बोला था कि इसके लिए आयोडोफॉर्म टेस्ट के लिए क्या होना जरूरी होता है, तो कार्बोनाइल कार्बन तो होना जरूरी होता ही है। अदर देन दैट कार्बोनाइल कार्बन के बगल में एक CH3 ग्रुप होना जरूरी होता है। अगर CH3 ग्रुप है तो पॉजिटिव टेस्ट देगा, अगर नहीं है तो नेगेटिव टेस्ट देगा। मतलब नेसेसरी, दिस इज द नेसेसिटी दैट देयर शुड बी अ कार्बोनाइल कार्बन एंड द कार्बोनाइल कार्बन शुड बी connected with the CH3. If it is there, only then iodoform test will be positive, otherwise it will be negative. So let me take an example of aldehyde. If there is no CH3CO group, then it will give negative test. Let me explain you this one with an aldehyde. Okay. So I'm taking two aldehyde. One is benzaldehyde. So benzaldehyde is this one. Benzene having C double bond O H group. Okay. Next I have acetaldehyde. So acetaldehyde is CH3 C double bond O H group. Okay. So this one is my benzaldehyde. This one is my acetaldehyde. Okay. Now what will happen is it will be treated with NaOH and I2. This will also be treated with NaOH and I2 or alkaline iodine solution. Okay. Now what will happen is what I already mentioned you that the carbonyl carbon must be attached with a CH3 group. In this you can see the carbonyl carbon is attached with the CH3 group. Okay. But in this case, right in this case, what you can find is the carbonyl carbon. On one side you have hydrogen and the other side you have this carbon being bonded with three other, here is a carbon, here is a carbon, and here you have a double bond. If it is like this, here you will have double bond, sorry, here you will have a carbon, here you will have a double bond, here you will have a double bond, here you will have a double bond. What am I trying to say is this carbon is no more a CH3. Hence, there will not be any reaction. Or we can say it gives negative test. This one is your negative test. Okay. But in case of acetaldehyde, what am I going to show you is this CH3 group is going to reduce into CHI3, which is what we call iodoform. Okay. It gives yellow PPT, yellow PPT, along with the liberation of. So the other part is there, it will convert into H, C double bond O, O N A. Okay. Along with the liberation of water and NaI. So major product over here is your CHI3 or iodoform. Okay. Let me move further that what type of ketones basically. So let me take ketones again. Let me take acetophenone. The first one I'm taking acetophenone. So what is acetophenone? Acetophenone is basically benzene ring phenone. So obviously you will have a benzene ring. Okay. And you need to have C double bond O and CH3 group. Okay, so this one is your acetophenone. Then, and next you are having benzophenone. I'm taking an example of benzophenone. So I have a benzene ring, C double bond O, and again a benzene ring. Both of them are ketone. Okay. But in this case, it is named as acetophenone, and this one is known as benzophenone. Okay. When they are being treated with I2 and NaOH or alkaline solution of iodine, what will happen is we cannot see any, in this case, what we cannot see is we cannot observe any CH3 group being attached with this carbonyl. Hence, it will not give any reaction. क्या बोला था मैंने कि कार्बोनाइल कार्बन के साथ एक CH3 होना चाहिए बट यहाँ पे आपको क्या दिख रहा है कार्बोनाइल कार्बन के साथ एक CH3 जुड़ा हुआ है मतलब ये पॉजिटिव टेस्ट देगा और ये रिएक्शन क्या करने वाला है इट विल डू द रिएक्शन and it will again give CHI3 which is a yellow precipitate or iodoform yellow PPT. Okay, along with the liberation of other byproduct like you will have C6H6 C6H5 that is benzo group. Okay, so over here you will have C6H5 C double bond O and here you will have O and A group and the remaining byproduct that is water and NaI will be formed. Okay, so simple what am I trying to say you is over here acetophenone gave the positive taste but benzophenone gave the negative taste. Before what was right there is the acetaldehyde gave positive taste but the benzaldehyde gave negative taste. So you need to mark on all this. Okay. Once kindly study it properly, hear it properly. I hopefully believe that you will be able to understand. The last we have is action of methanol with ammonia. So how is, again, I found this question. So let me go for this as well. Action of methanol with ammonia. What will happen when methanol is treated with ammonia? So HC double bond OH group. This is your methanol. And we need to treat it with ammonia. Okay. So this is gonna form a complex structure. Okay. When we are treating it, it forms basically hexamethylene tetraamine. So the structure we will have is hexamethylene, so CH2 6 and N4. So this type of complex structure will basically be formed over here. So it's simple when methanol is treated with treated with ammonia, it forms hexamethylene, tetraamine. Okay, along with the liberation of water. So what is right over there is you will have one N over here in the center. Okay. With this N, there will be the connection of three CH2 groups. So CH2, CH2, and CH2. Right in the next corner, what I kept is the three other nitrogen. Okay. Now what will happen is over here, let me make a benzene type hexagonal structure. Okay. And two spatial lines from here. Now here I kept a CH2 group. Here I kept a CH2 group. And here I kept a CH2 group. Okay. So you can observe the four now one at this point, one at this point, one at this point, and one at this point. And the three six CH2 group right at this point, this point. Okay. So this structure is basically known as we call it urotropin. Urotropin or hexamethylene. You might have a question like how will methanol react with ammonia or what product will you get and what is the structure? So this type of question can be asked. So if you have any queries, do ask me in the comment section. I'll try to make a videos to reply you all. And further, I'll be keeping some of the questions in the comment section. So kindly do the description box, kindly do that. And if you like the video, don't forget to share it with your friends. Thank you.